We'll turn our attention to triple integrals in just a moment, but first, let's just do a little review question. Right, so let's rewrite the double integral from negative 3 to 0, integral from negative root 9 minus y squared all the way up to 0 of e to the x squared plus y squared dx dy as a polar integral, or rather a double integral in polar coordinates. Okay, so first let's draw a picture. This region here, first in its original rectangular description, is the set of all points x, y, which satisfy, from the outside integral, we see negative 3 less than or equal to y less than or equal to 0. And from the inner integral, we see that x goes between negative root 9 minus y squared and 0. So this is just one of many ways to describe, well, let's see. We're going to be under the x-axis, and x less than or equal to 0. So we're left of the y-axis as well. So this should be all of the points that are over here. Yeah, so circular radius 3 filled in, but only the quarter circle, just the part in the third quadrant. So we should redescribe the same region in polar coordinates, r theta. Okay, so this should be r is between 0 and 3. Yeah, so we do have points like, let's say over here, where the r value is 1 or 1.5, 2, 2.5, 3. So we've got all those r values between 0 and 3, but we're not picking up all theta values. Yeah, I think the most natural way to say this is theta between pi and 3 pi over 2. Okay, so let's set up an integral. This dx dy part is, of course, going to become an r dr d theta. Let's go ahead and I guess we'll just keep writing backwards here. So e to the r squared. Hope that looks okay for the replacing the x squared plus y squared. And we've got integral sign, and the inner integral is the r integral, so it should go from 0 to 3. And the outer integral is pi to 3 pi over 2. Okay, so this here is equal to that integral right there. Now, let's say I think you should try to take a moment to try to finish this integral. It can actually be done. Unlike the one up here, I think that's going to be way too painful. It just doesn't seem to work out. But over here, just think about the indefinite integral, just this inside integral here. Integral, without the numbers 0 and 3, of e to the r squared times r dr. This is going to be fantastic if you just do, the hint here is do u is equal to r squared, right? So maybe parentheses here is technically helpful. So if you do u is equal to r squared, then du over dr is equal to 2r, right? So du equals 2r dr. That's going to work out great. Okay, let me just say that we're about to start a new topic, but it will be important, very important, to master double integrals in polar coordinates. Now, let's say this. It won't be really the main topic of this. We're going to look at triple integrals for this day and the next day, but then immediately after, we're going to take a look at something that's like polar coordinates. For 2 days, we're going to be talking about cylindrical coordinates, and then 2 days after, we're going to talk about spherical coordinates. Both of those coordinate systems are quite a bit more challenging than polar coordinates, so this concept here, doing double integrals that are written in polar coordinates, has to be done and understood. Otherwise, when we get to that, so I'm not talking about today, I'm not talking about tomorrow, but I'm talking about 3 class days from now, and for 4 class days in a row, the next topic will be quite a disaster if you don't take a look carefully at integration using polar coordinates.